Hi, my name is Nazrin. My matrix number is 230070. For task 1, question A, it asks for the demand function and assume it is a linear. So we let demand function as Fp equals to Mp plus C as first equation, which Fp represent demand, which is attendance at price P. M is the slope of the line and C is the y-intercept. Given the 2 points in the question, when the price is 30 ringgit, the attendance is 13,000, and when the price is 20 ringgit, the attendance is 23,000. We can find the slope using slope formula and get answer for the slope is negative 1,000. We substitute the slope value into our first equation. So we let the next equation is second equation and substitute any point given from the equation to find our y-intercept C value, which is 43,000, and our last answer for demand function is Fp equals to negative 1,000, P plus 43,000. So for question B, how should ticket price be to set maximize revenue? We let revenue Rp equals to price time with the demand function, and we get Rp equals to negative 1,000 P square plus 43,000 P. So the maximum revenue equals to vertex of Rp, and we can get the price P equals to negative B over 2A, and we get 21.50. So to maximize revenue, the ticket price should be RM 21 ringgit 50 cent. That's all for question 1. Thank you.
Hi, my name is NURUL FATHIHAH binti Mazin. My matric number is 231077, and I will explain to you guys about question number 2. So let's start with question number A. So we assume X is the number of years after 1993. So we find the year 1995 equal to 2 and year 2008 equal to 15. So these two values is our endpoints. So next we will find the critical point. So how to find is we need to differentiate our equation, and then we will make it equal to 0, and we can find the value of X. So we will find the two value of X, which number one is 12.562 and the second one is 3.1046. So we will assume the first value as 13 and the second value as 3. So we substitute back our X into our equation. So the answer for value 3 is 96,325, and for the value of 13 is negative 128,075. So the question asks about the membership. So it is impossible the membership will be negative. So we need to find the value, and if we refer to the table, we substitute one by one, and we will find the largest number of membership is in 1996, and the smallest membership is in 1999. Okay, next we move to question B. So it asks us to find the largest increment. So we need to find the changes of each years, and we will see for each years the largest value is 31,255, which is between the 15 year and the 14 year, which is in 2007 to 2008. So that is the largest increment. Okay, that's all for question number 2. Thank you.
Hello, my name is NURUL with matrix number 228615. So for question 3, first thing we need to do is to declare what is our X and SS represent for. So X is month after declare candidacy, and SS is a part of voters in percent. So for question A, we need to do first derivative differentiation for our equation that are given. So the answer is negative 3 over 29 x squared plus 12 over 29x plus 63 over 29. And we need to equal to 0 to find the critical point. And we got x equals to 7 and x equals to negative 3. We need to ignore our negative 3 because x is represent for months. There is no negative in months. So our answer is x equals to 7. For the second part, we need to substitute our x into value of 0, 7, and 12. For x equals to 0, we get the answer 37.24%. When x equals to 7, we got 50.76%, and x equals to 12 is 33.52%. So in conclusion, the maximum support she get is approximately 50.76%, which when month X is 7. Therefore, the politician should announce her candidacy 7 months before the election, which on April. For question B, my answer is yes, because she will have approximately 50.76% of voters at that time.
For question A, what selling price will bring a maximum profit? So first thing first, we're gonna search the profit, which is sell minus cost times number sold. So we put the equation, which is sell X, cost C, and number sold is the N given. And we will get an equation X minus C, A in the bracket A minus BX plus 100B minus C. So after that, we're going to differentiate that equation, and we will get 2A minus BX plus 100B minus C minus A minus BC. So in with that equation, for the maximum profit, the equation that we differentiate equals to 0. So from the equation that we already got, equals to 0, and we will get X equals to A minus B plus 1C minus 100B over 2 in the bracket A minus B. So for question number B, the backpacks that can distribute if we want to have 1 million ringgit. So we know how many backpack is N, the number sold. So we will 1 million equals to N times X minus C, because we want the profit. So we will get N equals to 1 million over A minus B plus 1 C minus 100B over 2 A minus B minus C. So when we solve this, we will get N equals to 2 in the bracket A minus B times 1 million over B minus A plus 1C minus 100B. Because the value of A, B and C is not given, so we will leave our answer like that. So the answer is the company has to manufacture and distribute N equals to 2A minus B times 1 million over B minus A plus 1C minus 100B to have a profit 1 million.
Hi, Assalamualaikum. I'm Nazrin. For task 5, question A, it asks for the time of maximum listener. So, from the original function, we need to find the first derivative, and we get set 34 over 7 in bracket negative 6x squared plus 50x minus 103. So, the first derivative equals to 0 to find the critical point. So, we get the first x equals to 3.72 and the second x equals to 4.61. So we need to do the second derivative in order to determine which of the factors is local minimum and local maximum. So for the second derivative, we get set 34 over 7 in bracket negative 12x plus 50. So we substitute back the x value into the second derivative. For x equals to 3.72, we get the second derivative value is 4.46, which is more than 0. Therefore, it is local minimum. For x equals to 4.61 into the second derivative, we get the value is negative 4.43, which is less than 0. Therefore, it is local maximum. Thus, the time of maximum listener at x equals to 4.61 hour, equivalent to 4 hours and 37 minutes after 5 p.m., which shows that it is 9:37 p.m. So, for question 5b, it asks what percentage of the population is listening at this time, which refer to the maximum time. So, we just substitute back our x value equals to 4.61 into the original function and get the final answer equal to 97.07%. That's all for task 5. Thank you.
My name is Cik Ashraf QUSHAYYI bin Cik Moh with metric number 228382. So for question 6A, we need to find coordination for P should be located. From the information given, we need to find distance from oil refinery R to P to Q, which is point on south bank, and Q to storage tanks S. With distance formula, distance R to P is search x squared plus 9 over 4. Distance P to Q is 2, and distance Q to S is search x squared minus 19 18x plus 90. And then all of them is timed with the cost of laying pipe over land and under the river. We will get the equation is SHARDDIN square plus 9 over 4 times 400,000 plus 2 times 800,000 plus SHARDDIN square minus 18x plus 90 times 400,000. After that, we need to do derivative for the equation and we equate it to 0. And we will get two value of x which are negative 9 and 3. We ignore negative 9 and we take 3 because the domain is negative 1 to 10. Next, we need to do second derivative to search for minimum. We substitute value x in the product of second derivative. We get the minimum cost. Finally, the coordination for P is 3, 2. For question B, we need to find cost for construction to lay on pipe point P. We just need to substitute value of 3 in the x where we get the distance just now and we get the cost, but we need to times it with 400,000 and the cost is 1,341,640 and 79 cents. Thank you.
Hi, my name is FASIHAH. My metric number is 228741. I will explain number 7. So we need to solve the inequality first. Given HP is more than 0.5, then we cross multiplying and simplifying, we get the PQ more than 0.5 PQ plus 0.5 minus 1.5 P plus 1.5 P square minus 0.5 PQ. So we multiply both sides with 2, we get the 2PQ more than 1 minus 3P plus 3P square. Then we move the right hand side to left hand side, we get the 2PQ minus 3P square plus 3P minus 1 is more than 0. Insert the value to the calculator, we get P is more than 0.5. So, therefore, the winning party needs to receive more than 0.5 of the popular vote to win more than 50% of the seats in the House of Representatives. For questions B, we need to calculate voters first. 75% of 36 million Malaysian is 27 million voters. So we multiply with the answer from A, we get 30 million and 500,000. To win more than 50% of the seats, winning party needs more than 30 million and 500,000. So the winning party needs at least 30,500,001 votes. So, therefore, the expected minimum number of popular votes is 30,500,001 votes.